Hey, hi everyone. Welcome back. This is the video 32 Polymorphism of Object-Oriented Programming, Module 5 from H&M Technologies online training. We are continuing our journey through object-oriented programming. Today we are tackling a concept that sounds like a scary, but it's actually one of the most elegant problem-solving tools you will use in your career. That is polymorphism. Let's break down the word polymorphism. Poly means many. In the same way, morph means forms, like many forms. In programming, it means that a single method name or a operator can behave differently depending on the exact object it is interacting with. Think about the English word play. If I had you a piano and I say play, you obviously press the keys. And if I had you football, then I say play, you'll kick it. Then if I had you a YouTube video, then I said play, we'll exactly press the play button. The command play is a exact same everywhere, but the execution changes depending on the object. That is a polymorphism. When you are building a massive applications for your final year projects or working on a tech industry or you're working on a freelance for a projects, this concept allows you to write a incredibly flexible and clean code. Let's see now method override. The foundation of polymorphism is a method override. This happens when a child class takes a method from its parent class, who is in a previous class, but completely rewrites the logic to suit its own need. Right. Apart from the parent class, whenever it's need, it's without changing to in a parent class, it automatically child the child class. That is called a method overriding. Let's imagine we are building a notification system for a startup. We have a generic notification parent and specific types of notifications like email and SMS. Now open your VS Code, create a file name polymorphism.py, okay, and type this completely whatever you'll see in here. And first of all, understand what I'm typing here. Now let's see our first parent class. Our first class is a notification, and I define here send self. In a send, I give a parameter self, then I try to print here sending a generic notification. Then I'm creating my child class, first child, that is a email. Here my class name is email notification, and I define and I take a dunder in it self command. I assigned again a self.email address equal to email address. Here I'm overriding method to take a new form, and I'm defining before that I define sending a generic undefined notification, and now I'm overriding that connecting email server and sending email to self dot email address. Now I'm taking another child class, my second child, that is SMS. See here my class name is SMS notification. This is my child class, so I'm taking these parameters from my parent class, which is a notification. So that's why I'm here notification. Then I'm defining here the under in it. Here I want a phone number, so phone number. So I'm defining phone number self dot phone number equal to phone number. So right now I'm overriding a method because I want a different one to for SMSs. So I define send self. Here I'm printing connecting to cell tower. Then texting to whom, texting to self dot phone number. Now let's test our code. My email, I'm giving email notification xyz @gmail.com. And for my text, I'm giving here I'm calling SMS, another child class, SMS notification. And then I have to give parameter. That is here we are giving arguments. That is data. What is that SMS notification? We have a phone number we have to give. That phone number is in a text format. So in the string format. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. That is a phone number. We call our classes that we have a rewritten method. First I'm calling my email dot send. See the output here. Connecting to email server, sending email to XYZ. So in our child class, we rewritten this connecting to email server, sending. You can see that sending email to self.email address. This is what we rewritten here. And actually, what is in a parent class? In our parent class, we have sending generic undefined notifications. But as per our need, we rewritten this in an email. In the same way, we call our SMS. See what is output in. Our SMS we give my text, right? My text is dot send. I call my text dot send. See the output. Cell tower texting 1, 2, 3, 4, 5 the number. In the same way, how we method reworded here for email. In the same way for SMS notification, I rewritten this one. See, connecting to cell tower texting self dot phone number. See, inside the child class we have the exact same method name, send and send dot send self. Same method name here, send. Same method name here also, send. Everywhere same method. But the logic takes many forms. The email connecting to server, the SMS connecting to cell tower. Okay, that's what polymorphism. The logic is same, everything is same, but it's transformed into many forms as needed. When we call my email.send, Python knows exactly which version of method to run. This makes our code highly predictable for other developers too. Now next polymorphism with functions. Now let's see why this makes you a 10x developer. Because our object shares the same method name. We can write a single universal function outside of our class that can process any notification object we had it. This is a polymorphism with the functions. We'll see. I have a class email notification. I am copying my email notification. So yeah, this is my email notification class, and there I define email connecting to server, right? So let's see. Now I'm taking my another child class, which is SMS. Yeah, we have two child class. One is class notification and SMS notification. These are the two classes that we saw before. And now I'm going to write a polymorphism function. I'm defining a function alert user. Here I'm taking parameter notification method. And then in this method, I'm going to print a system alert and triggered. I'm testing the code. Now I'm giving the data, right? So I'm calling alert user before we create a polymorphic function. Alert user. Here I have to give him saying email alert. So when I say email alert, see the output system alert triggered connecting to email server, sending email to the admin.@gmail.com and alert successfully delivered. Now if I say SMS alert, see SMS alert triggered connecting to cell tower, texting the date and the number we gave here. Okay, then alert successfully delivered. Look closely at a def alert user notification method. The function is brilliant. If your company decides to add a push notification or a WhatsApp notification next year, you can do not have a change this function at all. As long as the new class have a send method, this function will process the flawlessly. That is the power of polymorphism. Now let's see duck typing. It is very crucial for tech interface. What you just saw perfectly illustrates a famous method Python philosophy called duck typing. If you have a technical interview coming up, older stricter languages like a Java or a C++, a function checks an object's exact class type before it allows to run. Python doesn't do that. Python uses a duck typing. Python says, I don't care what family tree this object comes from. I only care if it can perform the action I am asking for. Let's look at a fun concrete example. See here, I am having two unrelated classes, no shared parent. One is a class duck, one is a robot. So don't have a parent class. The two have unrelated classes. Okay, one is a sound like a pick quack, the duck, and one is a robot that sounds a beep and robot. And now writing a polymorphic here, define make it a speaker entity. Okay, right? Now a Python doesn't check a class type, okay, before which class it is, and it just blindly trusts an entity dot sound. Okay, then I am testing my duck typing, and real duck is a duck and my robot. Then I am testing my function and make it a speak real duck. Real duck is what speak quack quack, and make it speak. My robot is speaking like a beep bop. I am robot. Duck and robot have a zero relationship, but because they have the method called sound or make it speak function treats them identically. That is duck typing. Python focuses on behavior, not a strict type like there must have be a relation between the two classes. It doesn't care about this relation. It only care about the methods. To finish off, let me blow your mind. You have been using a polymorphism since the first week of this course you without realizing it. Think about the uh, addition operator. If you do 5 plus 5, Python performs a math, gives you 10, right? If you do data plus base, Python merges the string and it gives you, you see, if you give data plus base, then it gives you a database like this, merging the two strings. The addition operator takes many forms depending on the data type. What if you want to use the addition operator to add our own custom object together? We can completely customize Python's built-in operators using operator overloading. Now let's see this. Here I'm having a class order, item, price, and here, and self.item, and the magic method is add self and other has a combined price self plus other order price. Okay, now return the combined price. Now testing the code. Laptop order is a laptop and 1200. Now mouse order wireless is a 50. See here our class is a class order, and here I'm in our class I'm defined a self and item and the price. Okay, then here you can see def add dunder add a self other order. The other add method is what Python secretly looks for behind the scenes whenever you type the addition symbol. Okay, now we literally reprogrammed the line, the addition sign here for order objects. When we do laptop order plus mouse order, Python pulls the price, adds them, and splits out the brand new bundled order object. See here, and a combined price, self price plus other order price. Now total return price is return order combined bundle, combined price. Okay, now let's see what happens. Testing the code. Laptop order laptop 45,000. Okay, now mouse order is a wireless mouse and that is a 500. Now I must type this total cart laptop order plus mouse order. Now I'm printing total cart item combined bundle and Price is C. Total cost 45,500. This proves that Python everything is polymorphous if you know how to weld it. You just learned that polymorphism means many forms, user methods overriding so child as on customize their behavior, and polymorphic function and duck typing focus on what objects can do rather than what it is, and you even overload the plus operator, which is addition operator. You are writing incredibly advanced adaptable Python code, right? Now I'm giving you a few practice questions here. See here, practice questions. Question 1: create a 3 classes: a car, airplane, and the boat. Then give each class method named move. Car should print driving on the road. Airplane should print flying through the sky. Boat should print sailing on water. Okay. And third, create a polymorphic function called start journey vehicle, and this inside this function call a vehicle to move, and then create an object for each of the 3 vehicles, which are a car, airplane, and boat, and then pass each object into start journey function to seek duck typing in action. Okay, master this, and your code will become incredibly professional then. And next time we dive into encapsulation and abstraction to protect your data. See you there. Thank you for choosing H&M Technologies online training. Happy coding, and bye bye.